Well, hey guys, I thought I would make this video to give you all some support based on questions that many of the students that I've worked with struggle with the most. That's why I call these unusual ACT math questions. Most of the time, these questions will be found in the last half of the math exam from question number 30 to 60. I always refer them as application-based, conceptual types of problems, because you really got to be thinking out of the box sometime to really solve these. I'm going to make a series of these videos covering many different years that the ACT has been given. Hopefully you will find them helpful. And with that in mind, I think we need to get rolling because it's going to take about an hour to get through all this. So here we go. The first question you see two triangles. And the question says, what is the measure of angle C? Well, they've drawn two triangles. They've given you the angle in triangle DEF is 42 degrees. And in triangle ABC, they're asking you what the angle is at C. The question says, in the figure shown below, triangle ABC is similar to triangle DEF. You should have been able to pick this out of the picture based on the information given. One triangle smaller, they label both side lengths. The other triangle's larger with one side length labeled. So they're implying with the figure similarity. So triangle ABC is similar to triangle DEF. Sides AB and sides BC are each 7.2 centimeters long. Side DE is 10.8. And the measure of angle E is 42. What is the measure of angle C? So with similar triangles, we're going to have all the same angles in both triangles. But what type of triangle is this specifically? So by the information given, they're implying that these are isosceles triangles. And what do you know about isosceles triangles? That the angles A and C and D and F would be all the same. My next question to you is, how many degrees are in a triangle? Well, 180 degrees. How are we going to leverage the 180 degrees and the 42? Well, if you subtract the 42 degrees from 180, you get 138 left over. Now, with that 138, since both angles DF and AC will be the same, we can divide that by 2. When you divide 138 divided by 2, you get 69 degrees. So therefore, angle C is equal to 69 degrees, which is answer choice E. Now, many people could have just looked at the figure, looked at the information there, and just said, oh, they're talking about similar triangles. didn't even have to read the question and then made the calculation. I realize not everybody's the same, so that's why I went ahead and read the question. But for those of you who don't need to read it and you just can make that inference based on the images, then it's pretty safe to do so. Although I would find the question within the paragraph just to reassure myself. All right, let's move on. So now we come across this particular problem that in the question, it says we're dealing with the sine. It says f of x is equal to 0.25 times the sine of 4x. It tells us that x is between 0 and 2 pi. That's just a definition. Don't worry about it. It just means we can't go out of 2 pi with this particular graph. We can't extend it further, in other words. All right. The period of the waveform is the first full rotation through 360 degrees. That's the period. So the first full revolution or rotation going from 0 all the way back to the x-axis, from the origin all the way back to the x-axis, one time. That is the period. With that in mind, if you look at the x-axis, the units are in radians. If we start at 2 pi and count backwards, we can figure out how they came to pi. So we go backwards, one full rotation, one more rotation. So that's 2 full rotations. If we divide 2 pi by 2, that gives us pi. Okay. So now we need to go back one more rotation. And we're splitting those 2 in half. So we're going to divide pi by 2. And that's going to end up getting us to the first 360 degrees, which is equal to our period. And therefore, our answer choice is F. All right, let's keep moving on. In this particular question, we're going to deal with simplifying the expression that they gave us. So we're going to take this equation, x squared plus 5x plus 6, which is all divided by the binomial x plus 2. I like to put parentheses around that. That reminds me that's a binomial, plus x plus 5. Now, look at your answer choices. Your answer choices are in much more simpler form. So we've got to find the answer that's equivalent to the expression that we have. So that means we got to simplify this thing. So the numerator, we're going to factor. You've got an x squared as a leading term, so you got an x here and an x here. We've got 6 as the constant. So we need to figure out 2 numbers that we can multiply to get 6 yet add together to get 5. So 3 and 2 work. And notice that we have 2 positive signs in the quadratic equation right there. So therefore, we're going to have a plus sign here and a positive sign here. And notice they're all divided by x plus 2. Now we're going to put plus x plus 5. Now we're dividing here. So that means that this binomial in the denominator, x plus 2, can cancel or divide out the x plus 2 in the numerator. And that leaves x plus 3 plus x plus 5. Now let's clean up what we have. We have 1, 2, we have 2 x's, and we have a 3 and a 5. So they end up being added together to give us a total of 8. So now what we've started with at the top of the screen, we have simplified into what we have at the bottom of the screen, 2x plus 8. Therefore, our answer choice is B. They love to do these types of problems. Just be prepared for them because you can be guaranteed it's going to be there. This is also another highly favorable type of problem on the ACT, determining shaded areas. So look at the question. What is the area in square feet of the shaded region bound by the circle? Well, just by the drawing, we know that the larger circle has a radius of 10. The smaller circle has a radius of 6. Okay. And we're talking about area. So the area of a circle. Area of the small circle is going to be equal to pi r squared. Area of the large circle is going to be equal to pi r squared. Take the information that they gave us in the figure and fill in the numbers. So pi, the radius of the small circle is 6. 6 squared. Pi, the radius of the large circle is 10. So 10 squared. So here 6 squared is 36 pi. 10 squared is 100. And don't forget the pi. Now, that's the total area of both circles. If we subtract those areas from one another, it leaves the shaded region. So 100 pi minus 36 pi. And with that being said, that's 64 pi. That turns out to be answer choice J. I'm going to emphasize again, the ACT loves to calculate shaded regions with figures. So be on your toes for them because you're going to see it. It's probably about an 80% chance of seeing this on an exam. Let's move on. Now, as soon as you see this, you see the letter I. I implies complex numbers. There's some things that you need to remember about I, and one of the things that's most important is I squared. I squared is equal to -1. When we're dealing with I squared in an equation, we always substitute -1 for I squared to simplify the equation. Okay, with that in mind, Notice they have 1 plus 2i squared. And they say, well, what is that equal to? People not substituting -1 for I squared is one of the first mistakes that's always made. The second mistake that's always made is people like to take your 2 and square the 1 and then square the 2i. That is the wrong ideology. This means 1 plus 2i times 1 plus 2i. This 2 means we have 2 of the binomials. It's like, for instance, a squared. That just means a times a. Same concept. Now, with that in mind, we need to multiply the 2 binomials together with the process of what's called FOIL. So 1 times 1, 1. 1 times 2i is plus 2i. Now, 2i times 1 is plus 2i, or positive 2i. And then 2i times 2i is a positive 4i squared. Now look, our I squared comes in to play. Now remember, we have to substitute -1 for I squared. So that's what we're going to do. 1 plus 2i plus 2i is 4i. Plus 4 times a -1. Now let's clean this up. Positive 4 times a -1 is a -4. Let's put all of our common terms together. A 1 and a -4 is a -3, with left over a positive 4i. Now we have simplified this binomial into -3 plus 4i, which will be answer choice A. All righty. Let's move on to the next one. But before I do, please memorize this. I squared is equal to -1. It will be highly likely that you will see this on the exam. Okay. So our next question comes up, in which we have a question that is going to be very descriptive about what we must do with the problem. So let's read it. The volume of a right circular cone with a radius r and a height h is 1/3 pi r squared h. They give us the volume formula for a cone. And they say where r and h have the same unit of measure. They say cone A and cone B are both right circular cones. So they say cone B is 2 times the radius of cone A. So stop. Let's say the radius of cone A is 2. So then the radius of cone B has to be a 4. Now you see what I did? I took their instructions and I used some small numbers for us to use in this equation a little bit later. They go on and say cone B's height, h, is 1/2 cone A's height. Well, if cone A is 4 for the height, then cone B's height has to be 2. Now we have our radius and our height for both cone B and cone A set up properly. And they told us how to set it up. They just didn't tell us what numbers to use. You could have used any number you wanted to, as long as it fit the statements. But when you choose numbers to fit statements like this, choose small ones. Make your math as easy as possible. Now the question says, compared to the volume of cone A, the volume of cone B is what? Well, look at your answer choices. The same, half is great, 2/3 is great, 2 times is great, or 4 times is great. So we're comparing them to one another. So that means we have to calculate the volume of both cones. And we're going to do so by using the formula that they gave us. So 1/3 pi r squared h. 1/3 pi r squared h. Fill in the numbers. So cone B, the radius is 4. The height is 2. Same thing over here for cone A. The radius for cone A is 2. And the height is 4. Okay, let's start to clean up our mathematics. So 4 squared, 16. I'm going to do this step by step. I know some of you could have just jumped to 32, but I don't know who's watching it. And let's be polite to everybody. So 2 squared is 4. So 16 times 2 is 32. Four times 4 is 16. So what we have is 32 over 3 times pi. We have 16 over 3 times pi. Now, when you do your math, 32/3, and you multiply it by pi, you get a decimal of equivalent of 33.51. No, I didn't do that in my head. I had it written down. Okay, so 16 divided by 3 times pi is 16.75. Now, how do they compare? Cone B to cone A, right? Compared to the volume of cone A, the volume of cone B is what? Well, cone B, 33.51 divided by 16.75. With that being said, that is 2. So cone B is 2 times as great as cone A, which leads us to imply answer choice 2 times as great, D. There's a lot of mathematics there. Some of you will be able to do it real quick. Others won't. For those of you that are going to encounter this problem and your math skills are weak, you have an option. You can either tackle this problem and take more than 1 minute. If you take more than 1 minute, you risk missing or leaving questions after this problem blank because time is ticking away. If you can't see a clear pathway to solving a math problem on the ACT math exam and even the SAT math exam, skip it, because they're all worth 1 point. Go get the points that are still on the table that you haven't even seen yet. And perhaps something with the questions that you haven't seen yet will make you think about something on how to solve this quicker, so you can come back to it. Okay, let's move on. Now, this particular question gets everybody. There's been very few students who've been able to solve this in the past 11 years that I've been helping young adults with these questions. One of the things that you can do to really help yourself is make a sketch. Make a sketch so that you can understand the paragraph better. And sometimes you come to vocabulary words that you just don't know. And if you don't know those vocabulary words, it's going to be tough to solve the problem. So let's walk through this one step at a time. From point A, outside of a circle, stop. Let's sketch it. Here's my circle. It says from point A, outside of a circle. So here's A. There's its point. It's outside of the circle. You could draw it anywhere you wanted to. For the sake of fitting all this on the PowerPoint background, I put it to the left. I could have put it to the right. From a point A outside a circle and in the same plane as the circle, 2 rays are drawn tangent to the circle. Stop. 2 rays. So 2 rays are drawn tangent to the circle. So that means one ray is going to go like this and the other ray is going to go like that. They're going to be tangent to the circle. That means they're going to touch one point on the circle. And since they originate from the same point, they're going to touch the same point on the opposite sides of the circle. So here's one. Here's my first ray. It's coming out. It's coming out. It's coming out. Now, granted, it's not the best line, but hey, I think you get that idea. Well, they're supposed to touch. Okay, so they touch exactly one point and one point only. Here's the other ray. It's coming here. It's going towards the point. This one I got drawn a little bit better. And it's going to hit my point, and it's going to touch that circle right there. 1 point only. That means they are tangent to one another. So 2. Now that we've got this sketched, what do you recognize in the drawing? We know angle A is 70 degrees based on what it says in the paragraph. If angle A measures 70 degrees, what is the measure of triangle ABC? You see the triangle developing? Look between here. Now draw a line like this. You see the triangle? A, I'm going to call this B. I could have called this B down here, but I chose not to. C. So what type of triangle do we have? You see the hidden figure now? Hidden figure. That figure wasn't obvious in the beginning, but now it is. This is really important concept because the ACT, when it has drawings, you can always find another figure within the drawing that leads you to more information that has not been presented in the question. And that extra information gives you extra details, math knowledge that you can apply to solve the problem. So our hidden figure was a triangle. Well, what type of triangle? Well, it turns out from here to here and here to here, the same distance. So this is an isosceles triangle. What do you know about isosceles triangles? In this case, angle B and angle C will be the same magnitude, the same value. So a triangle has 180 degrees in it. We're given 70. If we subtract the 70, we get 110. Now, B and C will be split among the 110. So 110 divided by 2. 5, 5. Therefore, B and C are 55 degrees. And in this case, it is answer choice G. Important things are going on here, guys. And with that being said, please look for hidden figures. Anytime that you see a figure drawn on this math test. All right, let's move on. Okay, so we come to this one. This one's pretty interesting. They want you, well, let's just read the question. It says graphed in the standard coordinate plane below is an ellipse. The center of the ellipse is 0, 0. And points -5, 0, 0, 3, 5, 0, 0, -3. Point A, which is 3, A, and point B, 3, B, lie on the ellipse. What is the distance in coordinate units from A to B? So let me do this. I'm going to draw on top of the figure. So let me change pen colors. So they want to know the distance from here to here. Let me silence my phone so it won't interrupt us. Okay. So what could help us? What could help us here? We have a y-axis, we have an x-axis. What's missing from those two axes? A scale. So let's draw in or sketch in a scale. Just do it the best you can, because you know you're here at 0 and you count up to 3. So make your marks as best that you can, as equivalent as you can, all between them. Okay? Now, project point A over here, like so. Project point B over here, like so. So here's 1, here's 2, here's -1, here's -2. So this area here is about 2.3, 2.4, 2.5, somewhere in that area. For safety's sake, you can just say it's about 2.5. From here to here is about 2.5. Now, the total distance based on our approximation is 5.0. Look at your answer choices. There's no way it can be 6. So E's gone. There is absolutely no way it can be 4, because 2 is less than where the dot is at, right? There's no way it can be 3, because 3 is at the top. And there's no way it can be 2.4. So our 5.0 models answer choice D almost perfectly. And how did we get there? By sketching in a scale on our axis. That's the easiest and quickest way I know how to get you to the answer. All right, let's change my pen tip. And let's get back to where we were at. Next question. Now, this particular question is placed where it's placed on the exam, and it's used to slow you down. It's quite involved. Remember, earlier I said when you can't see a clear way to your answer, leave it. I'm not going to leave this behind, but if you can't figure this out quickly, go get more points on the exam. So let's get to moving on this question. It says Carrie and Manuel are side by side when they begin to run at the same time in the same direction around a track. Carrie's rate, or Carrie runs at a constant rate of 30 seconds per lap. So Carrie, I'm going to put C. 1 lap per 30 seconds. While Manuel, M, runs at a constant rate of 50 seconds per lap. 1 lap per 50 seconds. Their rates are different from one another. So, our units are laps, 1 lap per, the L stands for lap, 30 seconds, S for seconds. 1 lap per 50 seconds. We got our rates mathematically laid out now. How many seconds after beginning to run will Carrie have run exactly 1 more lap than Manuel? Okay, so we can take Carrie and subtract Manuel. So we got 1 over 30 minus 1 over 50. Okay, well, we got a problem with our denominators. So we got to clean that up. I'm going to multiply 1 over 30 by 5 over 5. And that's going to leave me 5 over 30. So that's 5 laps over, sorry. I apologize. That's going to leave me with 5 laps per 150 seconds. Now I've got to multiply this one by 3 over 3. So that's going to leave me 3 laps over 150 seconds. So manual can run 3 laps in 150 seconds. Carry can run 5 laps in 150 seconds. The difference between the two is 2 laps in 150 seconds. Well, we need this into 1 lap, right? Because it says how many seconds after beginning to run will Carry have run exactly 1 more lap than manual? We can reduce this. So we can reduce this to, reduce it by 2, 1 over 75. So 1 lap, 75 seconds. So Carry has run exactly 1 more lap than manual in 75 seconds. With that being said, that's answer choice C. Although some of these math questions may have more math mechanics to support them, this question is a little abstract in nature, and not a lot of people are used to working with this type of problem at school. And it may be more challenging for you. If it is, don't worry. Again, if you can't see a clear way to the answer, don't waste 40 seconds thinking about it. Move on to the next question so that you will have additional time to work on the next question and get more points. Okay, let's move on. Here's another one of those questions. I seem to have grouped them all together. It's another abstract question. And I think the best way to go about this is just go straight to the mathematics that works. And you'll see what I mean by that in just a second. Consider the fractions 1 over a, 1 over b, and 1 over c, where a and b are distinct prime numbers greater than 3. All right, let me make sure I got the right color pen up here. I do. First of all, prime numbers. Prime numbers. Do you remember your prime numbers? Well, 1, 3, 5, 7, 11, and dot, 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 etc., right? Now, the question says prime numbers greater than 3. We know C is defined by knowing what A is. So that means we only need to use 2 prime numbers greater than 3. So we can't use this one or this one. But we can use 5 and we can use 7. The problem comes in with knowing which number goes with A or B. That's where this problem takes a lot of time, because to really work it out, you have to work it out almost both ways, unless you get lucky and you just happen to choose the proper way in matching up your A and B with your 5 and 7. Let's move on and you'll see what I mean. Okay. So 1 over A plus 1 over B plus 1 over C. Now remember, C is equal to 3 times A. So it says, suppose that A times B times C is used as a common denominator when finding the sum of these fractions. In order for the sum to be in the lowest terms, hence lowest terms, its numerator and denominator must be reduced by a factor of which of the following. So our factors here are going to be our A, our B, our C. And the numbers that we're using up here that are the prime numbers are going to help us to determine if it's A, B, or C. And that's why it's really important, or that's why most of the time you have to work it out both ways, with A being 5 and B being 7, or A being 7 and B being 5, to find which number can reduce your total. What I'm going to do is I'm going to go ahead and set A equal to, I think I need to set it equal to 7. Yeah. I need to set A equal to 7 for the sake of keeping this video short. I'm going to set B equal to 5. When I set A equal to 7, C becomes equal to 21. Now we got some numbers that make this less abstract, and then we can begin using the numbers to help us answer the question. So 1 over 7 plus 1 over 5 plus 1 over 21. We're adding, and in this case, we need to get common denominator, right? So in this case, the common denominator between these three numbers will be 735. To get 1 over 7 with a denominator to 735, we need to multiply 1 over 7 by 105. So we get 105 over, well, 105 times 7 is 735. Now we need this fraction to have a denominator of 735. So we're going to multiply 5 by 147. So that becomes 147. So 147 times 5 is 735. And the same thing for our last fraction. We need the denominator 735. So we multiply 21 by 35. And that gives us a numerator of 35. Now you can total all this up. And when you total all this up, you come to a total of 287. Yeah, you guessed it. I already have this written down. Over 735. So 735. Now, what number can we reduce 287 over 735 by? Well, it turns out the only number that we can use to reduce 287 and 735 is 7. So we can divide 287 by 7 and 735 by 7. And when you do that, we're going to get 41 over 105. Now, the number that worked was 7. 7 is the variable a. Therefore, in order for the sum to be in the lowest terms, its numerator and denominator must be reduced by a factor of which of the following? A factor of a. Answer choice B. Now, had I made A 5 and B 7, then C would have been 15. That would have changed our mathematics completely. If you want, you can work it out with A being 5 and B being 7, just to see it for yourself. But for the sake of not wasting your time, I'm not going to go through all that. By now, you guys should be at a point where you can do that. Okay, so what's our next one? A couple of more and we'll be finished. Okay, so the next one is this. If x and a are positive real numbers such that x to the 2a is equal to 3, then x to the 6a is equal to what? So x to the 2a is equal to 3. They tell us this. Then x to the 6a must be equal to what value? Okay. We know that this first exponential, and I want you to go back to thinking about the basic idea of how exponential functions work. So we have some number x raised to some power 2 times a gives us 3. I want you to think about the very basic idea. Some number raised to some power gives us 3. Think about exponentials. Well, 2 to the 0 power gives us 1. 2 to the first power gives us 2. 2 squared gives us 4. Now look at what we can use. You see this idea here, 2 to the first power is equal to 2. So therefore, 3 to the first power is going to be equal to 3. That makes mathematical sense. We need to apply this ideology here. So we know our value of x must be a 3. So how do we make 2 times a equal 1? Well, a has to be 1/2 because 2 times 1/2 gives us 1. So 2 times 1/2. That's going to be equal to 3. We know what x is. X is equal to 3 now, and we know a is equal to 1/2. Apply this knowledge here. So 3 raised to the 6 times 1/2 is equal to what? Well, 6 times 1/2 is 3. So 3 raised to the 3rd power is equal to 27. You know, because 3 times 3 times 3, right? 3 times 3 is 9. 9 times 3 is 27. Therefore, answer choice K. This is a good problem to learn from. Look how we had to take the overall idea of exponents and look at it from a fundamental standpoint and apply it to what looks more complicated, right? We took the fundamental ideas and applied them to a more complicated version. And once we did, we were able to find our answer. This is why I call some of the ACT problems unusual. They are very abstract in nature. They're conceptually based. These types of problems occur more frequently in the questions from number 30 to number 60. Questions number 1 to 29 do. They're always going to be the easiest. You shouldn't miss any of those at all in the first 29 or perhaps the first 30. Make it a goal to always get the first 30 correct. And then from 31 to 60, or get the first 29 correct, and 30 to 60, go into that section with the ideology of searching for problems that you can get correct. Because as soon as you read them, you know it. If you can get about, I forget how many it is. Let me see. I don't have it here. If you get the first 30 correct, then you need somewhere around 15 or 16 more to get a math score up into the upper 20s, say around 27, 28. So get the first 30 correct, get 15, 16 more. 30 and 16 is 46 math questions. Now you're in the upper 20s for your scale score. That'll help bring down some stress on you leveraging the math test against itself to help you get a higher math score. Okay, let's move on. All righty. So we come into this problem. We got 3 lines on a graph. They all share the same x-intercept of -4. The question says, what is the y-intercept of line S? So we're looking for the intercept of line S. But let's see what it tells us to help us get there. In the standard coordinate plane, lines Q, R, and S all have an x-intercept of -4. We already knew that. The slope of line Q is 1. So Q has a slope of 1. The slope of R is 2/3. And the slope of S is the average of the slopes of Q and R. So slope S is equal to the average of slope Q and R. So we know that one is 1 plus 2/3. It's the average. Okay, so we can figure out the slope of S. Well, 2/3 plus 1, we need to multiply 1 by 3/3. And that gives us 3/3 plus 2/3 divided by 2. Well, 3 plus 2 is 5. I'm going to put it below here. 5/3 over 2. Well, 5/3 over 2 is, you got to multiply the numerator by the inverse of the denominator. And so that becomes 5/3 times 1/2. So that becomes 5/6. So now we know the slope for line S is 5/6. Second thing that's going to be useful. Remember this equation, y is equal to mx plus b. Very, very useful, and I'm going to tell you, you are going to see this on the ACT. They always leverage this equation. They always like for you to calculate slopes. So make sure you know on different problems how to calculate the slope. So now we can set up our equation. M is 5/6, 5/6. Now, what does B tell us? B tells us the intercept, right? I'm now setting up the equation for line S. Now, what do we do next to figure out the intercept? We need to get a point on the line and substitute the values into y and x. The only point that we have is -4, 0. That's all that's given us. So therefore, y is 0. X is -4. Okay, let's do our math to clean this up. So 5 times -4 is going to be -20 over 6 plus b is equal to 0. I'm going to move the -20 over 6 over here. And I'm going to get a positive 20 over 6 is equal to b. So now we found the y-intercept. Well, notice it's not 20 over 6 in our answer, so that means we need to reduce. So we can reduce 20 and 6 by 2, and that gives us 10 over 3. What is the y-intercept of line S? It is 10/3. Therefore, answer choice D. The most important thing here is y is equal to mx plus b. You need to memorize that equation. You need to know how to use it, and you need to know what the variables stand for. M's the slope, b's the y-intercept, x is the x value from the point given, and y is the y value from the point that's given. You need to know how to use that information to figure out the y-intercept from using this equation. They're going to do this again. It's guaranteed. Guarantee you they're going to do this. All right, let's go to our last question. Well, you know, people are used to seeing graphs drawn straight like this, straight up and down. This thing is turned at an angle. Don't let that bother you, because there's still 360 degrees around O. You got it? There's still 360 degrees around O here, or what's called the origin. Let's read the question. As shown in the figure, AC and BD intersect at O. Given that X is between 180 degrees and 360, and that X is equal to 4y, what is the value of Y? We need to figure out what Y degrees we have. So they're labeling this line all the way around as X, and this as Y. Well, this little distance from here to here is Y2, right? So the first thing we can imply is X degrees plus Y degrees must equal 360 degrees. They give us another equation. X is equal to 4y. What is the value of y? Well, let's do this real quick. Substitute. We know x is 4y, so substitute 4y into x. 4y plus y is equal to 360. 4y and y is 5y. Do our math. Y is equal to 360 divided by 5. And 360 divided by 5. So 7 times 5 is 35. 6 minus 5 is 1. Bring down the 0. So 72 degrees. Y is equal to 72 degrees. Therefore, answer choice J. That was very simple, but a lot of young adults get confused by the way the drawing is developed. Don't let it bother you. Don't let it bother you. Just think about what you know about graphs and apply that information to the drawing that they give you. And in this case, you still got a 360 degrees around O. Okay, guys, I'm going to end it there. And I really hope that this has helped you. I hope that whatever you're struggling with, something that I've presented along the way may have kicked off a light bulb in your head, and perhaps you won't need any more help. Perhaps you will. And if you do, I'm going to make more videos like this moving forward from this point. I'm always wishing you all the best. And if there's anything that I can ever do to help you, please reach out to me. And hey, good luck on the first time you take the ACT or the second time you take it. And with that being said, don't worry about how many times you take it. Just take it with confidence and remain focused on the exam and not the time. If you get focused on the clock, that means you're distracted from the questions that's in front of you. Think about that for a little while. And we'll talk about that on the next video. All the best, guys.